All right, let's review, my friends. This is for your exam. Honestly, you know that there's no accident to passing this. It's the work, the studying, right? You put yourself in the right spot to get a good grade. So let's look at each one. I'll go through what it is. All these kind of questions will likely be on the exam. A function's continuous. That's important. F at 1 is -7, F at 2 is 3, F at 3 is 0, 4 is 10, 5 is 8. All right, what's the point? If F at C equals 1, then the intermediate value theorem would guarantee a C value in what interval? So the key is the Y value. So the Y value is 1, and in between, 1 would be in between what two Y values? So is 1 between -7 and 3? Yes. Is it between 3 and 0? Yes. Is it between 0 and 10? Yes. Is it between 10 and 8? No. So which of the ones that would work would be the interval between 1 and 2 and 2 and 3 and 3 and 4. And for all of these intervals, it would work because 1 is in between the two Y values. So on the exam, multiple choice, there'll probably be only one interval, right, to pick from. But what are you looking for? The Y coordinates. So in between the Y coordinates. So 1 is in between -7 and 3. It's in between 3 and 0. It's in between 0 and 10, but not in between 10 and 8. So that's the one interval it doesn't connect with. Number 2. Find a limit using your calculator, because this is a calculator one. So what would you do if you had a calculator to find the limit? Let's do it together here. So I want you to go menu, calculus, limit. Make this a little brighter. There it is. All right, limit. And then the limit is what? As x approaches 2. And then just start typing. So, control divide, you have a fraction, type in x cubed. So you can see it. Plus 3x squared. Subtract x. Plus 10. In the denominator is x squared. Subtract 4x plus 2. And you have your answer. -14. Use the graph at the right to determine which of the following is true or false. The limit from the right at 1 is equal to 3. So I find where 1 is. From the right, the answer is actually 3. It works. The function has non-removable discontinuities at x equals 1 and -1. That means the limit does not exist. Is that true? Does the limit not exist there? So at 1, does the limit not exist? Yep, that one works. At -1, does the limit not exist? Nope, the limit exists here because the left and the right agree. So this is non-removable, this is removable. So this one's false. The limit as x approaches -infinity. That's the left end behavior is going to infinity. So is the left end going to infinity? True. So the answer is 1 and 3. That's the truth. Number 2 is the false one. All right, calculator question. This means just derivative at 3.4. So how do we do that with our calculator? Menu. Oh, turn it on. Menu, calculus, derivative at a point. We are using x, the value is at 3.4. And then type in. So what would you type in? 2 to the exponent, the square root of x. Move the cursor, plus 1, and that's it. Go control enter. It's going to be a decimal, 3 decimal places, so 1.349. A spherical balloon is expanding at a rate of 80 inches per minute, cubic inches. At what rate is the radius changing when the radius is 3? So we start with this. We have one variable on the right. So we're going to take the derivative with respect to time. So the derivative of v is 1, but with respect to time, it's dv by dt. We're going to take the exponent times 4/3. That's the 3's cross out, so it's 4. Subtract 1 to the exponent, it's 2. But it needs the hook, dr by dt. This is a related rate. Then plug in the values. So 80 cubic centimeters per minute is the volume. That's the rate the volume's increasing. The radius is 3. And then my goal is to find this. At what rate is the radius changing? So this is 9 times 4. So that's 36 pi. So divide both sides by 36 pi. And the answer is you don't need to reduce it down. 80 over 36 pi. And it's centimeters per minute. So that rate is the rate the radius is increasing when the radius is 3. And if you had to reduce it down, you divide top and bottom by what? 4, right? 20 over 9 pi. All right. Where is the derivative at 0 non-existent? Well, at 1 it isn't, because at 0 it's a corner. 2 is okay, but 3 is a vertical tangent right there, a vertical line. So at 1 and 3, the derivative doesn't exist at 0. It's a corner, it's a vertical tangent, so it'd be 1 and 3. All right, if the function's continuous, and you have these values, and these second derivatives, at what x value are we have a relative extrema? It's going to be the second derivative test. So first of all, -2, 1, and 3 are all critical numbers because the derivative is equal to 0 at those numbers. So -2, 1, and 3. To have a relative extrema, that means a maximum or a minimum. So at -2, the second derivative is negative. It's concave down. So at x equals -2 then would be a local maximum because it's negative. At 1, it's greater than 0. So that would be concave up. So at x equals 1 would be a local minimum. And then at 3, there is no concavity. So 3 doesn't give you a maximum or minimum. So can you use the second derivative test here? Number 8, at time equals 2 seconds, the acceleration of the object is -4.5, and the object's velocity is 10 feet per second. Use local linearization to approximate the velocity at 2.2. So this is very similar to this idea, but we're going to adjust it. So normally we'd want an x value, a y value, and the slope. But in this case, we have a t value, which is 2. Instead of y, we have velocity. And the velocity at 2 is 10. And then slope. Well, derivative is slope. Well, the derivative of velocity is acceleration. So the acceleration is actually the slope. So what number is the slope? -4.5. And then we write the equation down. You can write it with x if you want, or t. So I'm going to write down -2 plus 10. So that's the x and y, if you like, 2 and 10. And then it says to plug in 2.2 to approximate it. So if I plugged in 2.2, and you could use your calculator, 2.2 take away 2. It would just be 0.2 plus 10. So just use your calculator. So -4.5 times 0.2 plus 10. And I get 9.1. So and then you could do feet per second. So make sure you remember the units. So the approximate velocity at 2.2 seconds would be 9.1 feet per second. All right, the figure above shows the graph of the derivative from -10 to 10. At what values is there a relative minimum? So there's a relative minimum when it goes from a negative to a positive. So -7 is a minimum. A negative to a positive is a minimum. That's 5. And those are the only two spots. So at x equals -7, and at 5 we have minimums because the derivative goes from a negative to a positive at those numbers. Number 9, can you find these limits? The limit 3 to the right. So here's 3. From the right, we're looking at the y-coordinate, so the answer is 3. At -3, the limit does not exist because there's a jump. Infinity means the right-hand behavior, so it's going to infinity. List the x values of removable discontinuity. That's where the limit exists. So right here, the limit exists, which is at 3. And then the non-removable, the jump, which is at -3. And the asymptote, which is at -1. Number 14. Find the derivative. So the derivative of the top is 3x squared plus 1 and 4x cubed. And then the derivative at 1. So if I plug 1 into the top, the answer is 4. If I plug 1 into the bottom, the answer is 4. But, there's something here. What happens if I plug 1 into the top? The answer is 1 cubed plus 1. There's going to be a jump here. So from the left, the answer is 2. From the right, the answer is 1. Because there's a jump, even though this derivative would look like the answer is 4, this does not exist. Because where it's not continuous. So at 1, it's not continuous. If I plug 1 into the top, the answer is 2. 1 into the bottom, the answer is 1. They don't agree, there's a jump. The derivative doesn't exist at a jump or any discontinuity. So even though when you take the derivative, at the jump, the derivative matches right and left, it still doesn't exist because of the jump. All right, the graph of the derivative shown here on the right. We have intercepts at -1 and 4. And a maximum at 1. At what x values do we have a relative minimum? So that's when we go from a negative to a positive. So at -1 is a minimum. At what values do we have a point of inflection? So that's the turning point for the derivative. So that's at 1. Oops. Do we have a point of inflection? All right, no calculator. How do I find a limit without a calculator? So we're going to factor. We're going to divide out and then plug in 3 and get the answer 2. Here, what's the limit for 0 to the right? So here's 0 to the right. So just plug it into the middle piece and the answer is 3. How do you find the derivative? Well, we write it calculus friendly. And then the derivative would be 1/3 2x subtract 1 to the exponent, and then the hook, which would be 2. Done. Number 19, how would I find the derivative? Is I would do the quotient rule. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom and the bottom squared. Number 20 is the product rule. So that's the first times the derivative of the second, and there's a hook of 2, plus the second times the derivative of the first. We have to do this implicitly. So every time we take the derivative with y involved, we need to do a hook. -2xy is the product rule. So the first times the derivative of the second plus the second times the derivative of the first, which would be -2. And then 2x is 2, and then 10 is 0. There's step 1. Factor out y prime from 3y squared and -2x. On the other side, -2y will be +2y, and this +2 would be -2. And then divide to get your answer. So we have 2y minus 2. We have 3y squared minus 2x, and we have our answer. Find the intervals at which the function this is increasing. So we already have the derivative. To know whether it's increasing, we take the derivative equal to 0 and solve it. So we're going to factor out x squared and then solve it. So I get two answers, which are 0 and 2. We're going to draw a number line for the first derivative. Label 0 and 2. Now, to know where it's increasing, into the derivative I plug in. So if I plugged in negative 1, it'd be a positive times a negative, which is negative. If I plugged in, did I plug in positive? Negative 1. If I plug in negative 1, it's a positive times a negative. If I plug in positive 1, it's a positive times a negative. It doesn't change. And if I plug in a number bigger than 2, it's positive. So where is it increasing? Is from 2 to infinity. Here, it's decreasing. For this function, in this interval, find the c value that satisfies the mean value theorem. That's where a rock equals I rock. So, first of all, a rock, we're going to first find f at 0 and f at 3. So if I plug 0 in, the answer is negative 1. If I plug in 3, the answer is 8. So it's 8 subtract negative 1. And then the denominator is 3 take away 0. So if I solve it, the a rock is equal to 3. Then take the derivative, which is 2x, make it equal to 3, and then solve it. So that's c value. So you find the a rock, make it equal to the derivative, and then solve it. And that's in the interval, and we found the c value. How do you find the absolute minimum? That's a table of values question. So first we're going to put in negative 1 and 3. Then we're going to take the derivative equal to 0 and solve it. So here we're going to factor out a negative 4x squared. So when I factor out a negative 4x squared, the two answers are 0 and 3. Make sure both are in there. So I already have 3. I just need 0. And then you plug that into here. So if I plug in negative 1, I get negative 1 minus 4. If I plug in 0, I get 0. If I plug in 3, this is the one that will take a little more effort. Let's see. So that's negative 81. That's 27 times 4. Is that 108? And then 108 take away 81. Is that 27? It took a little more effort. So the absolute minimum is negative 5 because it's the smallest of all the y values. All right, find the x coordinate of the point of inflection. See how far I'm going to go in this one video. It won't be all one video. I think this will be the last one. All right, so find the x coordinate of the point of inflection. So let's do that. How do I find that? It's the second derivative. So we do the first derivative, 4x cubed minus 6x squared minus 1. Make it equal to 0. Oops, the second derivative I said. Take the derivative again, 12x squared minus 12x, now equal to 0. Factor out 12x, and then solve it. So there are two numbers, when you factor it out, that are critical numbers to the second derivative. That's 0 and 1. So we're going to draw a number line with 0 and 1 for the second derivative. Then into the second derivative, we're going to plug in a negative 1. So negative times the negative. Then I'm going to plug in 1/2. That's a positive times a negative. And then I'm going to type in or plug in a number bigger than 1. And then see if the concavity is positive or negative at each interval. And then wherever the sign changes is a point of inflection. So at 0, we have a point of inflection. When you plug in 0, you get the answer 1. And then 1 is a point of inflection. You got to plug in 1. 1 take away 2. That's negative 1. Take away 1 is negative 2 plus 1. That's negative 1. I'm pretty sure. So you have 2 point of inflections at 0, 1, and at 1, negative 1. All right, Mr. G Math over and out. That's part 1. I'll do part 2 in a moment. All right. Till next time.